Yes,
mode.
now it's
No.
perfect.
Great.
Yeah.
So, good morning to everybody, and welcome to this FlashPhos workshop. This morning, we invite you to join a journey into a new chemical ecosystem where systemic value chains cross each other's, creating opportunities as well as challenges. And one of these is really about energy versus food in respect to phosphorus as the principal key secondary raw material involved. If we look at this slide, I tried to synthesize what you probably know uh, better than me. That is about the FlashPhos, let's say, proposal for a circular production technology, which will be explained later by our experts. And beside this, you see a synthetic scheme about the circular value chain. But here, actually, we are speaking about the systemic value chain, where we do not only recycle, but we upcycle the phosphorus in the various forms in which it is present within our starting materials to transform it into elemental phosphorus. And besides providing this phosphorus, we also provide elemental phosphorus, which goes upstream even more, providing proper raw materials for different sectors. This is the reason why we say that FlashPhos goals can be, let's say, resumed into three P ones that are a goal for planets because we actualize a disruptive transformation in the production process of P4, that is elemental phosphorus, by creating a symbiotic value chain crossing other value chains as well, centered on waste. And you see how many different valuable contributions we can give to the planet thanks to this novel process in terms of waste reduction, emission gains, catalytic effect, and also 0 kilometers global local supply network. We also provide a goal for people because we have created a think tank for intergenerational and interoperability and interdisciplinary network where all these expertise have to come together and develop new skills in order to provide the right catalyst for transformation. And finally, we have the purpose, which is essential as we are speaking about elemental phosphorus and products in general, which are of usage for the different industrial sectors. Besides phosphorus, we generate, for instance, additives as byproducts, which can feed different value chains, such as the ones related to construction and building. And again, coming back to the circular value chain scheme, we can see that many different are the sources for phosphorus recycling. It is about industrial biowaste, it is about manure and slurries, it is about meat and bone, different waste. It is also about sewage sludge and ash from urban wastewater and industrial wastewaters. It is also about recycling of batteries, exhausted batteries. And the applications are wide as well. We are today focused on the applications within the energy sector and the food sector. Why did we choose food and energy? Because as we can see from this very generic slide with updated numbers, we see that batteries is not only related to e-mobility, but is related to the modern society as a whole. We have batteries within drones. Unluckily, we can experience it at the moment. We have batteries in the wired communication instruments. We have batteries to feed the quantic computers, which are essential in order to guarantee the global communication network we are facing every day in our daily life as well. And we also see how phosphorus is involved in these sectors by being one of the principal raw materials involved in many different technologies within the energy sectors, such as solid-state batteries and liquid electrolyte-based batteries. We see here in this diagram in red, phosphorus is representing one of the major components in the lithium manganese ferrophosphorus battery based and also lithium ferrophosphate based batteries. On the right side of the slide, we can also see that the lithium ion battery demand in general is expected to grow by about 27% annually to reach around 4.7 gigawatt per hour by 2030. And it's not only Europe, it's Americas, its Asian market, is all around the planet. If we go to the agricultural and food sector, we see that phosphorus is the principal raw material to develop fertilizers, animal feed supplements, antibiotics for animals as well. You see from this cake diagram how much phosphorus impacts on the food sector. And this is why, therefore, say that we have an opportunity. This is a challenge when we deal with phosphorus. And we are doing it because we are speaking about a systemic value chain rather than a circular value chain. Because we know that in the complex systems, policy interventions can result in risk migration from one circular value chain to another value chain. And this is what we're speaking about today with our relevant experts, which I now introduce to you before starting the different conversation. We have today with us, and I am glad to introduce them all, Professor Eliana Quartarone. She's full professor at the University of Pavia, head of energy materials and electrochemistry, as well as manager of the Renovate European Initiative. We have also Barbara Palacino Blasquez, PhD at the University of Zaragoza, expert in the industrial ecology and soil preservation for agriculture. She's manager of the Nenufar project. So here we will have Renovate, Nenufar, and also FlashPhos. We have Tabea Nickel from the Phosphorus platform in Germany, representative for the policy and regulation cluster of the platform. And we have Carlos Galeano, that is the Beyond Innovation Department Director at Italmatch Group, as well as Managing Director of Phosphorever Company. Matthias Raps, which is not only the environmental engineer and research scientist previously involved in University of Stuttgart, but also a specialist and I would say the real initiator and promoter of the FlashPhos project. We have Lucas Paul from the University of Stuttgart, expert in groundwater pollution and thermochemical processes. Luigi Di Rienzo, engineer and industrial project senior manager at Italmatch Chemicals, project leader for FlashPhos. And we have Christian Schmidt-Berger, University of Stuttgart Department for Energy Conversion, and as well FlashPhos project coordinator. I also would like to thank Heidi Grosch, that is our assistant in the FlashPhos project, as well as moderator today, and also Lena Lope, that was the organizer of today's workshop. So I leave the floor to the first speaker, And I thank you for your attention.
Thanks a lot, Maria Cristina. So the first topic we have now for the next 30 minutes, you will be entertained by the people in charge, or the people introducing the three projects. They will talk about the project spotlights and show where phosphorus matters in the current value chains.
So I hope everybody can see my screen in full presentation mode and can hear me as well.
Yes.
Yep.
Okay, perfect. Then also welcome from my side. And thank you for the introduction. So we have different projects who concentrate on the recovery of phosphorus from different sources and aiming for different products. So I want to start giving you an introduction of FlashPhos. So as you might know, the main product that is aimed for in FlashPhos is white phosphorus. So why did we choose to aim for white phosphorus and not as the other projects like Nenufar or Renovate to their products? So white phosphorus is one of the key elements for the phosphorus industry. There are many applications for example, thermal phosphoric acid, which is a very clean phosphoric acid used in the chip industry, for example. And elemental phosphorus opens the door to the complete production of all phosphorus derivatives, since it is the universal keystone for modifying and adapting the element and the molecules. So we see white phosphorus as a critical raw material, and some might argue also it might be in the future a strategic raw material. So also to highlight a few industries and products that we have in our mind as one of the targets in the process chain to end up with the phosphorus that we want to recover is, for instance, in the food industry, or as I mentioned at the beginning, in thermal phosphoric acid for the production of electronics, or as Maria Cristina already said, for the for the batteries used in the e-mobility, or what is also quite an important frame is the fire protection as a flame retardant. So now you know what our goal is and why we use white phosphorus. Now I want to show you how we want to recover the phosphorus and what is our input. Our input is starting from the top, or basically from the top left, is the sewage sludge or phosphorus-rich residues, for example, sewage sludge, which is the main input for our process, and of course some additives which are needed in the optimal case, also containing phosphorus. So these two streams are going into our FlashPhos process, which contains three major steps. It's the first process step is a dry and grinding step to reduce the water content from the dewatered sewage sludge, and simultaneous grinding the material so it's usable for the second process step, the flash reactor. In this process step, the chemical energy of the sewage sludge is used to combust or to gasify the sewage sludge, producing a gaseous fuel and reducing some of the heavy metals and producing a heavy metal concentrate. The slag will be, which contains the phosphorus, will be transferred to the last process step of the FlashPhos process, which is called the refiner. There we use electrical energy to produce our main product, white phosphorus. This will used in various industrial processes, as we saw on the previous slide. During the reduction of the slag, there will also produced an iron alloy and a cement substitute, which can be used in different industries. So, and of course, it's a high temperature process, which means we produce a high quality and on a high energy level process heat, which is available for synergies with other processes or internal within the FlashPhos process. And the material loop, and especially for phosphorus, will be closed using the consumers and back to the disposal industry, for instance, the sewage treatment plant. So far, that's the technical concept of FlashPhos. And now I want to give you an idea of how the P4 value chain at this moment looks like. So it's a linear approach going from left to right, starting with mining of phosphate rock, adjusting the proposition of the raw material, mixing it by coke and silica, feeding this raw material into the reduction furnace, which is in most cases an electric arc furnace, going on with a phosphorus condensation and producing, based on the product you aim for, flame retardants, batteries, or as it is shown in the picture, electronics, and ending up in the consumers. So to give you some numbers that we are talking about, in 2023, it's estimated mine production of 220,000 kilotons of production of phosphate rock, which is mainly almost half produced in China. And there are some reserves, and the largest reserves are located in Morocco. As already Maria Cristina showed you in the introduction slide, only a minor part of the world's phosphate is used for producing a P4. In the European Union, there is only which is completely dependent on phosphorus imports, and the total number of what is missing or what is imported from lands or countries outside of Europe is 50 to 60,000 tons of phosphorus per year. So how does FlashPhos fit into this value chain? So okay, now my computer is working again. So this linear approach is getting bent a little bit, and the main chain will stay as it is, but from the end users, there is the possibility now to use the FlashPhos technology to close the material loop and go back to the material mixing, or already to the reduction furnace, as the reduction furnace is already considered as a part of the FlashPhos technology. So there you create a material loop, phosphorus recycling the phosphorus that is existing in Europe already. And sewage sludge, as highlighted here, has 300,000 tons of phosphorus, is the potential of the source that is in phosphorus. So it's compared to the 50 to 60,000 kilotons per year of phosphorus that demand is. So there's quite a good chance to deliver the required phosphorus from sewage sludge. So at the end, I want to give you show you the FlashPhos consortium consisting of 17 project partners from with different backgrounds, universities, chemical engineerings, manufacturers, and guys from the cement industry. And of course, you are welcome to follow us on LinkedIn and our newsletter and visit our homepage for our latest information in the blog. So that's from my side.
Thanks a lot, Christian. Barbara, do you want to go next with Nenufar?
Yeah, thank you. Share my screen. Okay, so first of all, good morning, everyone. I would like to thank FlashPhos project to inviting Nenufar project and inviting me to be here today. My name is Barbara Latino. I work at CIRS, which are a technological center in Zaragoza, Spain. And we work on research, innovation, and development of in fields of sustainability, resource efficiency, energy networks, and renewable energy. And more specifically, I'm part of the area that is focused on resource valorization, bioeconomy, and climate change. And in this presentation, I will introduce the Nenufar project, which I'm the technical coordinator. Yeah. So Nenufar project is about new governance solutions and value chains addressing the recovery of nitrogen and phosphorus from the three main ways that we have in the European Union, which are manure, which is sludge, and dirty wastewater, as Christian mentioned before, sewage sludge, which are these waste have a high nutrient load, so they are a good alternative feedstocks. In this project, we have four main innovations that will be addressed, which are the methodology to estimate nitrogen and phosphorus emissions from fertilizer application, new governance models, the innovative economic and financial incentive for public and private entities, and a set of technologies to treat these different ways that we have. We are right now in the middle of the project, so we have some results that we will see in this presentation and some that are ongoing. We are 21 partners in 10 different countries around the European Union, which we have universities, technological center, industry, and other organizations. And as I said before, we are focused on the three main ways that we have in the European Union, which are animal manures, sewage sludge, and dirty wastewater. We have a huge amount of these waste in the European Union and with a high content of nitrogen and phosphorus. And as you can see in the two maps, which are nitrogen concentration and phosphorus concentration, we have a huge amount of these nutrient in the European Union, so we can avoid this emission, avoid this contamination, and get these waste as an alternative feedstock to recover this nitrogen and phosphorus. So it's a win-win situation. Our value chains is use this waste in a circular economy as I mentioned before, as an alternative feedstock to introduce this in the industry or with different treatment and valorization this nutrient and recover this nutrient as a new biofertilizer, and then use with soil application and with mitigation of this contamination, just to to get this nutrient in the soil context. So in this project, we have 3 main demo sites based on the different river basin. We have the first river basin, which is in the Ebro River Basin in Spain, and we treat animal manures with the technology of ammonia stripping to recover the nitrogen. Then we have switches sludge in the river of Lielup, in the river basin of the Lielup, which include the countries Latvia and Lithuania. And in here we have composite to recover this phosphorus. And then we have the wastewater in the river basin of the Danube. And here we have 2 countries, Hungary and Slovakia, and 2 different technologies, a membrane with pre-oxidation and a natural solution based on algae production. And we have then 2 followers with different logistic and different value chains based on their location and the situation, Denmark and Cyprus, and they will adapt their value or the value chains of the main demo site to set in the different logistical situation that is based on Iceland and the different waste production that they have. Here you can see our in this picture, the 2 different technologies of treatment that we have based more in the recovery of phosphorus. We have the compost of waste sludge to recover and to get this phosphorus and avoid the emissions. And then we have the algae production based on the wastewater of the dairy industry to recover the high load of phosphorus in this water, let's say, and produce new biofertilizers. Right now we are on rollout of at an industrial scale and a high level of scale, because in the beginning of the project we are working on the design of all the technology and design the recovery of this nutrient. But right now we are working on the second part of the project based on the industry technologies and industry recover amount. Not only we have this technology and all this treatment, but also we have based on the tools that I mentioned before in the monitoring and assessment of these flows. We have a scheme for stakeholder collaboration, value chain redesign, and enabling technologies, and obviously pilot on regulatory and financial incentives. So based on all this work, we want to, and we are working right now in policy recommendations, novel business and financial models, and capacity building materials based on these new value chains, on these new alternative feedstocks for, in this case, phosphorus and nitrogen recovery. So in our first search and our first work based on all the regulatory and legal directives, we make a search at a European level. We have all the general nutrients management regulation, and then specific policies for nutrients management. As you can see, we have gaps and barriers, and then these gaps give us opportunities to this new circular economy. Obviously, we have barriers like data limitation, climate change, obviously policy restriction, lack of target policies. We have something with economic instrument. We don't have a lot of economic instruments for these new value chains, and technological and social barriers as innovation and lack of knowledge. And then we have opportunities based on this, based on sustainable agriculture practice, healthier soils, policy supports and regulatory updates, financial and market-based incentives, and research innovation, and promoting this new and best practice. Not only we have this European level, but also we have this national and regional policy level. We have searched these different regulatory and legal concepts based on this nutrient management, and we saw some results that will be adapted So we have a regulatory importance because it's essential for nutrient management and recovery, not only across Europe, but also at national and regional level, because there are differences between national and regional frameworks that create barriers, but also opportunities. We have a lot of barriers because we have inconsistent between the European Union and national rules, even though we have difference at the same national level but different regional frame rules. So this is a barrier that we found in this project, and obviously operational and environmental complex challenge that need to adapt to traditional agriculture to this new practice and more sustainable and to the ecosystem. Then we have opportunities. We have examples in Denmark that they have innovation-friendly regulations, incentive for biogas and waste stream, and in Spain and Lithuania we have bioeconomic strategies to support these new value chains, this new circular economy based on nutrient recovery and recycled fertilizers market. Then we made some recommendations that are develop a more flexible regulatory framework, allowing for regional adaptations, then promote economic instruments to facilitate these new nutrient flows, and improve public perception and acceptance of the recycled products and among farmers and consumers, and provide financial support to farmers and encourage training in these new nutrient recovery technologies. And policy integration, proper transposition of this European regulation at national and regional level. As I said before, we have different regions in the same country that have different regulations. So this needs to be something that unify and something homogeneous. So is something that is essential for success of projects like Nenofy in this case, or we need to coordinate effort and policy integration at all levels to establish a sustainable circular economy model across Europe. So more or less it's an overview of our project, the first results of our project. We have a website, we have a LinkedIn page. So if you want to know more about Nenofy, you can go to our website, join to our community of members, community of interest, and you will receive newsletter and all the information and all the news that we are ongoing with this project. So I think it's everything by my side. So thank you for your attention, and if you have any doubt, please can send me an email or join to our community of members, community of interest, and join the Nenofy project.
Thanks a lot, Barbara. So this makes two. So now I think Eliana, you are last on stage to give a presentation about Renovate.
Yes. Can you see my screen?
Absolutely.
Mm-hmm. Oh, great. Okay, thank you. Good morning again, first of all. Renovate is a European project focused on the recycling of LFP batteries, which is built on the complementary skills of 11 partners from 5 European countries, including research institution, academia, a big company, SME, and also a battery manufacturer farm, our manufacturer here in Italy with a core business, LFP batteries as core business, and one producer responsibility organization, which is supporting us with link to the regulatory frameworks. The main goal of Renovate is the demonstration at TRL 4 of innovative and sustainable recycling process for the European battery value chain, which points to reuse more than 95% of end-of-life batteries, but also battery components beyond the cathode active materials, so including metallic foil, plastic, and also graphite, with also a specific focus on the valorization of industrial side stream, in this specific case, the manufacturing scraps, but also chemicals and solvents coming from the recycling technology we are proposing. This is done by means a closed loop circular approach and with also an almost net zero carbon strategy supported by digital tools. Renovate aims at maximize recycling, enabling the circular economy by increasing the recycling efficiency through a selective separation of the battery components, to increase the recycling profitability, still limited in case of LFP especially, by recovery non-cathode components. And the Renovate ambition is contribute to give more knowledge on the direct recycling of LFP, both end-of-life batteries, but also manufacturing scraps, and also implementing some green metallurgical approach to extract the critical raw materials from black mass streams based on cobalt chemistries, in order to validate the potential adaptability to beyond lithium chemistry, like for example the sodium-ion batteries, where the same critical raw materials are included. We are following a closed loop approach, so all the recovered materials will, anode, cathodes, and also electrolytes, will be reused in the remanufacturing of new cells, and all the project outcome will feed a full life cycle assessment, including the costing analysis, and also a digital platform which is acting as a digital decision support modules, including all the complex predictive regulatory framework in order to enable the potential scale-up of the Renovate solution. The concept of Renovate is sketched here. We are working with exhausted batteries, but also manufacturing scraps that undergo to a innovative mechanical pretreatment, high voltage fragmentation, in order to separate the battery component and recover as much as possible graphite, the binders, fluorinated binders, but also electrolytes, in order to isolate the cathode active materials, which are maybe the more added value materials, and go through a direct recycling use in a specific case of LFP. LFP is the core of Renovate because the motivation is really strong. As well mentioned before by Maria Cristina, LFP is now the mainstream technology in the global battery market. First, in case of stationary storage application, due to high cycle life compared to the nickel-based chemistry, no critical raw material, several critical raw materials, like in case of NMC batteries. So with important cost advantage, since the LFP battery packs cost lower than the NMC chemistry, and very recently also with a significantly enhanced energy density, more or less 200 watt per hour per kilograms. That allows to LFP to also penetrate the mobility sectors, filling the gap in terms of performance with respect to the NMC device. Because with the 5th generation of LFP batteries, it's possible to produce pack size large enough to deliver this more or less the same energy density of NMC chemistry, so allowing the introduction in the EV sectors. This is really crucial for Europe since, as we know, LFP supply chain is almost entirely dominated by China, and more than 99% of LFP batteries in 2024 comes from that country. So this, of course, brings to an important question: where will all these LFP batteries go? Because LFP is not regulated in the battery regulation yet. And this is really crucial because phosphorus content in batteries is high, is already high, more or less 0.4 kilogram per kilowatt hours, distributed in several components, massive in the cathode, but also electrolyte and flame retardants, and is expected to increase. But phosphorus is also a critical raw material in any form, so landfill is not an option, but LFP batteries should be recycled, of course. And this is also important if we consider some recent study that calculated the criticality of energy storage solution. And from the results, we can see that LFP is really dramatically higher in terms of weighted criticality with respect to NMC, since this pressing demand of LFP batteries also in the electrification. Taking consideration that phosphorus rock is a critical raw materials, massively used in agriculture or fertilizer, whatever. So there is this initial question, batteries versus bread. That reminds us that we do not forget phosphate when securing critical raw materials for electrification. In terms of demand-supply prospect for batteries materials, actually, the phosphorus demand is expected to account for only 2–3% of the total global demand, estimated for the 2030 plus, with a very well-balanced supply-demand ratio. So phosphorus supply shortfall could be avoided. But the question here is not the shortage of phosphate rock, but it's just the wrong kind of rock. We know that global phosphate rock reserves are very vast, even if localized in few geographical area, of course, China. But not all of it is sustainable for the production of purified phosphoric acid, which is necessary for the production of LFP. But only a limited availability, more or less 5% of such rock is useful for the production of PPA. And of this 5%, only 1% can be used in the purest form to produce such precursor. So it's not a matter of phosphorus demand, rather on the lack of sufficient capacity that can ensure a stable European supply for the PPA. So it's really crucial. And it's important to understand that now it's necessary an efficient use of phosphorus resource, which in case of batteries, for example, could mean recycling. Even if the LFP battery recycling is still really challenged because in terms of economic aspect, profitability aspect, because we have still high operational costs compared to the low value of the recovery materials, as you can see from these bar plots. The lithium the lithium price dramatically falls during these couple of years in front of higher feedstock cost in terms of black mass production, scraps, and whatever. There is now an overcapacity of LFP recycling compared to the available feedstock, with a focus, of course, again, of China, but also South Korea. So it's important to find, to fulfill key conditions for profitability. First, clear business model, going towards a closed loop approach, but also foster the market demand, fostering the use of recovery and the recycling materials into manufacturing process, as the Circular Economy Act is claiming for. But also regulatory support with mandatory recycling content targets also for phosphorus, for example, and technical innovation to reduce energy consumption and reagent. And in this case, direct recycling in case of LFP is really crucial. It can ramp up the technology. And this is the focus of Renovates. Since direct recycling means to recover and reuse the cathode materials without any breakage of the chemical structure, but with a simple regeneration from a chemical point of view, with a wide possibility of method with lower process cost. And as a final slide, I would just point the light on this kind of next generation recycling with a lot of positive effect with respect to the conventional recycling technology that can further boost the profitability of LFP batteries and a more efficient use of phosphorus in terms of lower energy consumption, lower toxic gas emission, and a really higher revenue from an economic point of view. Of course, a lot of challenge in terms of direct recycling still to be faced because direct recycling is validated now at lab scale and should be scaled up in very short terms in order to make the LFP recycling sustainable. And that's all from my side, and I thank you all for your kind attention.
Thanks a lot, Eliana. Also very interesting presentation. To make sure that all of you, that you are not just sitting here or standing here in front of your PC and hope to get entertained, we have now we have actually two audience interaction sessions, so where we really ask for your feedback. So this is the first one, the first audience interaction, and Lena Löw from Steinbeiß is also in charge for communication in the FlashPhos project. She's going to run the first question to you. So we ask you to provide input to one question she shares here.
Yeah, I hope you can all see this. What I plan to do with all of you is a word cloud for the question, which conflicts do you see in Europe's phosphorus value chain? I mean, we already heard a lot of different challenges and conflicts. I think most of you might know how a word cloud means. So that means you just scan this QR code, or in case you can't do that with your mobile phone, just join at slido.com and type in this code. And then you can enter keywords. Please do not enter sentences. Please use only keywords. And in case you are or you have the same opinion as a word which is already mentioned, then use the exact same wording, because only then it appears a little larger than the other words. So I hope I can motivate all of you, also the speakers, of course, the panel, the panelists, and all other participants to just share your thoughts here.
Thanks, Lena.
It already looks great. Nice. I think it's really interesting to see this word cloud developing.
Yeah.
We still have some participants typing, so let's wait a little more. You can also type various responses, right? So if in case you now see something else and you think, oh yeah, that's true, I totally forgot that, then use the exact same wording to type this again and it will appear a little larger. But I think that's what already is happening.
Two very
also-
active participants.
Yeah, and Lucas,
One.
I see now the word data limitation here. That's actually nice because you will have your presentation about that topic just now.
Yes. We are
Yeah.
going to cover this for sure.
Okay.
Hopefully.
Yeah. So I think no one is typing anymore. Just to announce, maybe I think I will prepare like a summary of this workshop and also use the results of my audience interactions. So you might see them later in a blog article of FlashPhos.
Thanks a lot, Lena.
Yeah, but I think I can then stop sharing my screen. Thank you for your
And
participation.
thanks a lot for everybody
Thank you,
for
Lena.
providing your feedback and your inputs. As Lena just announced, I think our next topic on the agenda is Lukas Pohl from the University of Stuttgart. He spent quite some time, and he also spent his PhD on kind of identifying or on data models and data availability in the recycling sector. And so he is going to share the results and his work with you now.
Good day. I hope everyone can see the presentation and hear me well. So,
yep, perfect.
Very good. Yeah. So my name is Lukas Pohl. I'm working for the FlashPhos project, and I was responsible in order to find the best spot where to recover the phosphorus in Europe. So I'm going to talk about the importance of data to reduce conflict potential. And I'm going to start with an introduction on the processing roads of phosphorus. You may all know it, but as a short recap, there's the thermal road, which produces very pure phosphorus. And there's at the same time the wet road, where usually fertilizers are produced from. So what's the trade-off here, or why are there two roads? There's this thermal route, which has a high energy demand, and thus the price for the pure phosphorus must be a bit higher. So it needs this high purity in order to have a market. And there's the wet route with generally lower purities. It can be purified, but this also increases costs and has lower energy demands and is usually used in order to create phosphates for fertilizers. How did we start out with phosphorus recovery? So we know that sewage sludge is a phosphorus-rich waste, and we looked first at the sludge amounts in Europe. And later on, we had a closer look on 10 countries, the main sludge producers here, so the first 6, and the neighboring countries. And we found out, okay, the demand for pure phosphorus, so for the yellow or for the thermal produced phosphorus, this can be met from sewage sludge and the meat and bone meal that is available. So from the availability of phosphorus in recovery or secondary route phosphorus sources, we can meet this demand. So this is so far a good message. So there is enough, let's say, material or phosphorus in Europe. But the challenge are concentrations, and there are even two challenges, not only concentrations regarding mass concentrations in constituents, but also concentrations in areas. So we're going to face them too in this presentation. So the total phosphorus concentration in these phosphorus-rich waste streams is about 3 mass%. So when we look now at the waste amounts compared to the phosphorus that is inside these wastes, stored inside these wastes, the amounts are huge, very, very huge. So we have, let's say, we are going to face transportation difficulties, most likely. So what did we do in order to keep this transportation, let's say, challenges as low as possible or meet them as good as possible? We geolocated every wastewater treatment plant in the 10 countries, so urban wastewater treatment plant, and we also geolocated MBM plants, so meat and bone meal processing plants, but they are not shown in this presentation. And we added data to every data point, so to every sewage treatment plant. We added first, we analyzed sewage sludge compositions, we created a model, and then we added the predicted sewage sludge composition. So we have an idea, a rather precise idea about the total phosphorus amounts at the sewage treatment plants, and at the same time, the sludge amounts the sewage treatment plants are going to produce. So we identified areas where sewage sludges or phosphorus occurs in rather high concentrations. Concentration in this case means amount of phosphorus or sewage sludge per sewage treatment plant. So we looked at the densest spots in Europe, and we found out, okay, especially at these spots, it could be of interest, or the main, these are the most interesting spots to recover the pure phosphorus, so the phosphorus where we need to invest a lot of energy in order to get it. So what I want you to show in order to address these conflicts with data. So we have the demand for the pure phosphorus, for the yellow phosphorus. Then we have the phosphorus amount that we can recover from sewage sludge. We have the phosphorus amount that we can recover from MBM. And we have the phosphorus amount that is needed in order to create to meet the amount of fertilizers that Europe needs. So what we can read out of this, in theory, we can most likely cover the amount of yellow phosphorus that Europe has a demand for. But for fertilizers, we won't meet the whole demand only with recovered materials. We will need the phosphorus rock in order to meet this demands. So from a scientific point of view, we want to show you, or I want to show you, that data hopefully can, if someone wants to look at the data first and then create a plant, can address these conflicts by showing off areas of high density of phosphorus, and so sewage sludge and recoverable materials. And we recommend to recover the energy intensive phosphorus route there, or place it there, and use the remaining secondary resources for the fertilizer production, because we need less energy. Means we can be more efficient even when we only have smaller waste amounts available. And that's all from my side. I'm happy that I'm still in time, so I'm wishing you a good day, and feel free to ask questions.
Thanks a lot, Lucas. I think important is that I think it's not only the data that's currently in the database. I think it's also something that needs to be continuously to be maintained and utilized, I would say, by different areas. So very good presentation. Thanks a lot.
Thank you.
The next topic we have now I think so far we have mainly received information. So the next step we want to do is really to have 40 minutes, approximately still 40 minutes of discussion. The first part of the discussion is a guided panel discussion where we have invited a few panel speakers. Tabea Knickel, Matthias Rapf, Carlos Galeano, and Eliana Quattarone. And they will be now highlighted here in the presentation or on the board. The first question we would like to raise, so we have, like I said, we have first 20-30 minutes for the guided panel discussion, and then we will open the discussion for 10 to 15 minutes for the complete audience. So, but leave those people first a chance, or give those people first a chance to discuss, and then we will open for the broader audience. So I welcome all the panel speakers. Carlos, with very nice background. So the first question we would like to raise with you, and I think you have seen it in the agenda, we will talk about the potential conflicts and synergies. We will talk about circularity and innovation and policy and governance. So the first question that we have is around potential conflicts and synergies. Do you see any real conflicts between the different application of recycled phosphorus, and where may we find market conditions in which the different sectors can work together to use the available phosphorus streams more efficiently? We thought, so maybe Eliana, maybe you want to start with that, and then I think so we want to just make sure that everybody speaks a little bit here in this area.
Yeah, just a few words so I can leave the floor to the colleagues. We'll never speak to. I fully agree with the keywords raised up from the survey, because these are all interesting keywords that we are facing in case of recycling of phosphorus in the battery sectors. Pro issue related to the cost, and also issue related to the quality of the waste that can be used for recycling into something that can be reused for the LFP production. I just talking about batteries. I do not see any dangerous conflict between the different applications in terms of recycling phosphorus. Maybe because the battery sectors will go in the next future with a sort of inner circularity, which means that the simplest way to recycle phosphorus in the energy sectors, for example, is to recover the LFP from the end of life batteries, but also manufacturing scrap, which will be the main resource for the recycling of phosphorus. That's why I do not see really dangerous conflict with application, for example, in terms of agriculture or other sectors, fertilizer and so on. But of course, I see a lot of challenge in the recycling phosphorus, at least for the energy sectors. Thank you.
Thanks a lot. So I'm not going to call the other people, so I want you to speak up. I think normally we have to stop you. We don't have to encourage you to talk.
Okay, then I'll be next. I don't see any real conflict. I think we have different technology approaches. Each has its own quality, volume, and costs. Each pre-recovered technology is for its own independent. Synergies can appear if any process can be linked to another. For example, if phosphoric acid, recycled phosphoric acid, is used in another pre-recovery process. But I think Additional synergies can come from transparency, knowledge exchanges, and active networking. So with condition and shared platforms, sectors can work together efficiently and maximize the phosphorus streams.
Thanks a lot, Tabea.
Okay, I really would like to take the word that I completely agree with Eliana and also with Tabea, because the availability is there of the phosphorus coming out of the different secondary sources. The issue I see is that we first, for example, in case of Eliana will recover out of batteries phosphorus, hopefully. But the phosphorus that you will recover will not be produced in Europe. And if we produce FlashPhos, the phosphorus out of FlashPhos, you will not basically recover my phosphorus, which will be the ideal picture of circularity. No. Why? Because the battery components are basically the main consuming phosphorus are not produced, not fabricated in Europe. So I would like to see the full chain. I mean, to change instead of take a picture, to see the movie. And the movie here is that the most component, all components of batteries are definitively not produced in Europe. So this is the first point I see. Even if we produce the phosphorus here, and we will, by FlashPhos, as you saw before, the phosphorus will be used in different activities, but not specifically in the batteries. Because unless Europe decides to go for an integral policy to produce batteries here, but not to ensemble batteries, to produce all the components, electrolytes and cathodes and all these elements that are not produced and are basically not planned to be produced. Because we know last time, a couple of weeks ago, we had a conference in Brussels, and for example, LiPF6 is a fundamental element for batteries, for the electrolytes. And yeah, there's no single plant in Europe. A lot of plants are, a lot of projects, but at the end of the day, it's not. I mean, I don't see any conflict in the, let's say, in the offer demand for the P containing waste. Not at all. I see this is for everything, for everyone. There's sufficient there. I see a market where the offer will surpass the demand for the time being. Potentially could be a balance, but in the first 10 to 15 years, when we have all the projects running, we will have material enough in conditions to run. I don't see any conflict.
Yeah, I have some thoughts, Carlos. I like your this thinking very much, to see that in a globalized world, a real European circularity is not really realistic. So there's a lot there can be reality. But still, I have some new information today from Lucas. So I've not seen these figures before in the way you showed them, that we have I know that we have a really high demand for fertilizer, phosphate for fertilizers, but that it's so extremely much more than we really have secondary resources in Europe. I was not really aware. And say from the point of view of recovered fertilizer producers, there may be some kind of conflict, at least at first sight. Yeah. So we say we only need 10% of the sewage sludge, and they may say, well, but we want all of it. But on the other side, that is, I think, something that we have also often discussed. There are so many different qualities of sewage sludge on the European market, and also so many different conditions on which they can be collected, so that there is quite a lot of sewage sludge is not appropriate for the use in FlashPhos, for example. But there's also certainly a lot of sewage sludge that is not appropriate to be transferred into fertilizers. Yeah, that's why I also wrote in this word cloud, the lack of communication could be a source for a conflict. It's not a conflict, but a source for a conflict. So until now, it has also been mentioned, everyone does things on their own. Yeah. So we don't really know what these stakeholders do, what those stakeholders do. So they're all we say in German, they're cooking their own soup. Yeah. I think there's a very big potential for synergies, say for in the exchange between the different approaches. That's why also we meet today here, so that we are aware of each other in order to distribute what we have as usable sources to the right channels, so that we know there is a certain region where can be easily transferred into fertilizer. There is a certain region where sewage sludge is too dirty or too whatever to be used as fertilizer, but it could be usable for a FlashPhos plant, and so on. So I think that's this kind of communication made with platforms, with these exchange methods, or everything that Tabea said. I think this is something we need to keep up, to not make up a conflict that there actually is not. Yeah, as you say, Carlos. I also think there is not really a conflict, but it can become one if we don't communicate. Because we see also it's not only the need for fertilizer is the highest, also the number of stakeholders that aim for producing fertilizer is quite high. Although this is not really the picture we have in Germany, because in Germany, for example, that is the biggest producer of sewage sludge in Europe. The Germans, they aim for mono incineration of sewage sludge, meaning that they will ash, and the most probable way that we will succeed in recovering from ash is making acid or white phosphorus. So platform chemicals that can be used for quite everything. So I think there's a lot to find out how we can really manage these phosphorus streams intelligently without fighting where there is no fight necessary. So communication is key.
And if I may, it's a good point, Matthias. I think when we look at the phosphorus that we will produce with FlashPhos and deployment of FlashPhos, potential deployment in different markets, and we always talk about a consortia. Without a consortia, this will not work. And the consortia has key participants, or members. We have, of course, the sewage sludge generators, mainly the plants generating the raw material. But then we need a place, an industrial park, to place the phosphorus plant. Then this industrial park needs electricity. We need an electricity provider because our process is an electricity consumer. And then we need also a logistic operator, moving things in the most efficient way. And the last but not least, we need a consumer, let's say a company, an industrial company consuming the phosphorus, is the logical component, having an off-taken orders, and finally the investors. So once you collect all these consortia members, you will automatically fall in what you are proposing, Matthias, the communication, the investigation, see the most efficient way to keep it, because all these commitments will have to last at least 20 years. I mean, if you are going to invest in a plant in Europe to produce phosphorus, everyone who will invest will ask for a clear financial business plan or model. And this model has to be stable and sustainable. For this, you need commitments, long-term commitments for every participant, the ones I was mentioning. And this is, if you have it, then you means that you have already done your job or your homeworks, and you know exactly where to do, why to do, and how long.
Thanks a lot. We have
Carlos,
also received.
I could not agree more. Carlos, thanks for
Okay, thanks. I take this as closing words. We have some questions also in the chat. I see that to Lucas one, this has been already answered, so we are not going to cover that. I would like to go through our questions, and then I think first, and then when we at the end of the discussion we can raise the questions that were also here in the audience or in the chat. Okay, the second question we have thought about is about circularity and innovation. And I think, honestly, I think it has been a little bit answered. Will there be enough secondary phosphorus for all sectors? And will it be possible to plan the different P recovery activities from the beginning in a way that all take more or less part in the same P cycle? And I think it has been already answered, but maybe Matthias, maybe you start with that. I don't. So you have to unmute
it was
yourself.
my idea.
Yeah.
But already when we created this list of the three main topics, I almost assumed that there will be a lot of overlap of these two topics. So basically, I agree. So we really have already discussed it from my point. So I would not have anything to add. But Lucas is raising his hand.
Oh yeah, I missed this. Yeah. Lucas?
Yeah. Yes. So I have to admit that I created this bar plot rather fast and not too precise. So it is a bit comparison of apple and pears there. So the recovery potential of the sewage sludge and the MBM, this is MBM is whole Europe, but for the sewage sludge are only these 10 countries. So there should be a bit more of pure phosphorus to get out from the sewage sludge. But the 900 kilotons for used in fertilizer industry, this is for whole Europe. So not only for the 10 countries. So I guess the gap should be a bit smaller, but enough to get enough material to compensate the yellow phosphorus demand and the phosphate demand for the fertilizer industry. I think this cannot be met from only recycling materials, at least not from only sewage sludge and meat and bone meal. Maybe if we also include some steel slags, then maybe it can be risen a bit, but most likely we will rely on rock also in the future.
Yes.
Yeah.
But I think that is
But
a
Lucas,
number that is
Lucas, I have a question. I have a question. There is another source that this is definitely very, very difficult to go for, but this is the manure. You didn't mention manure in this, and this is a huge source of phosphorus, but claro, it's complicated and in some cases very strongly regulated. No?
Yeah. Okay. Yeah, you're right. So in our study, we only focused on the wastes that are currently, let's say, disposed via incineration. So sewage sludge, which is most like incinerated in Germany and Switzerland, and MBM is also only the share of the category 1, which has yet no recycling route or only partly, and the other meat and bone meal wastes like category 2 and 3, which already have a recycling route, we did not include. So in theory, if we would bend this recycling route towards fertilizers and so on, we may meet this criteria. You're right.
So I think also, Carlos, there is a lot of discussion about manure and so on, that it is not that is never accounted for when we make these phosphorus balances all over Europe. We say all of the phosphorus that we need in Europe is imported and da da da. And I think it's correct to say there is a lot of manure going around in Europe. I think most is used in agriculture. I think only little is thrown away. But on the other hand, Carlos, you know this also from we were in you live in Barcelona, we were in Lleida, where they have a big problem, as we have also, for example, in the northern part of Germany, that a lot of manure is produced where it is not needed for the agriculture. Yeah, so there are some approaches that try to extract the phosphates from the manure and extract other things like nitrogen and carbon containing and fiber containing and so on, and try to distribute them where these materials are needed. Yeah, so I think there is definitely a small number of people who really try to also recover the phosphorus from manure, while we may think this is not necessary. Yeah? Because the use of manure in agriculture is something that is quite problematic. So we have big contaminations of groundwater in regions of whole Europe. Yeah. So I think it's definitely something we need to also consider. I think it's quite long in the future, far in the future, that we can say that this will play a role, because the development is not so far. So nobody's really
okay. I think we lost Matthias. At least he seems to be frozen.
No gap. Okay. I was possibly frozen. Am I back?
Yeah, you were frozen. You were gone.
I think it's very important for the future.
I think Barbara also raised her hand, so I want to give her a chance to briefly talk.
Just briefly, because Nenufar is more or less about this topic, because Nenufar work with manure and recover nitrogen and phosphorus and try to avoid this emission and this all this contamination that we have. So yes, this is our problem. Now in Spain is not a problem at all, because we are focused on nitrogen contamination and phosphorus. But yes, in the rest of Europe is a problem, and that's why we try to recover this nutrient and make more efficient and sustainable with the soil and with all the application. Because as Matthias said, we have in Spain, in a specific country, we have a lot of amount of manure, not only in Catalonia and also in Aragon, which are the two regions that we work in environment. And yes, we have a lot of a huge amount of this waste, and there is not enough soil for this application. And that's why we work with a waste map to see where are the nitrogen and phosphorus focus, and try to find these flows and see how we can recover this nutrient without avoiding this contamination, and try to recover not direct application, let's say. Yeah, but this is a problem.
That sounds great. It's quite similar to what Lucas does. Yeah? So you make a waste map.
Yes.
So this idea is not so strange after all. So it's nice to hear. Do you have already contact with Lucas? Possibly you can have some exchange.
Yeah, well, I saw in the presentation, so I sent an email and talk.
Because he did it his way, and I would be at least interested in what is your approach to make this map, because we were confronted with a lot of problems with the data availability, with the data quality, and so on. So if you cover the entire areas.
Yeah, I would like now a little bit, because we have not unlimited time, honestly. I would like now to move to the third question that we have, which is around policy and governance. Does Europe need binding rules for phosphorus recovery? Or do you think that other governance approaches would even do a better job? So, and I think Carlos, you mentioned it already before, a consortia. But I would be interested. I think Tabea, maybe you want to take this first. I think you're muted. You have to unmute your.
Yeah. Can you?
We hear you
yeah,
well.
the question. Okay, perfect. Yeah, I think Europe needs clear binding rules for recovery. Because in the new ordinance for wastewater streams, there's no phosphorus recovery binding rule. It just says it would be nice if there would be a nutrient recovery, but not a binding rule for it. So we need the clarification that it should be done, the recycling processes. And it would be good if we have funding programs for investment security, market stability, and the scaling up potential. All of that networks and consortia important for coordinate, for knowledge transfer, and for speed up the replace of regulations, and that everybody knows how to deal with these regulations, which maybe can come in the future. So it would be nice if we have clear rules on the total crossroad for phosphorus recovery and other nutrient recoveries in whole Europe.
Thanks, Tabea. Anybody else, Eliana or Carlos?
How probable do you think it is? Oh, sorry. Just one short question, only very short. Just your estimation, Tabea. How probable do you think it is that in the near future we'll have such a binding legislation? Because now this wastewater Richtlinie, how do you say, this wastewater directive is quite new, and it is not to be expected that it will change very quickly. At least I don't.
Yeah, I'm not expecting that there will come a new obligation in the next years, but it would be very good if we had one, so we can promote this, and maybe then the EU regulation think, that would be a good way, and we need a regulation like this.
Okay, thanks, Tabea. Eliana?
Yeah, just a few points. In the battery sector, phosphorus is not still regulated. It's totally absent from the battery regulation, where only nickel, cobalt, copper, and lithium are considered just in terms of recovery specific targets, but also recycling content, which should mandatory also for phosphorus. Last year, the European Commission launched a public consultancy for the modification to the battery regulation in terms of how to monitor, to calculate the recycling efficiencies. And a lot of stakeholders, including the Phosphorus European platform, are asking to include phosphorus in the battery regulation, but also as phosphorus, but also as iron phosphate, including also graphite, of course, because it's really urgent. Because LFP is taking over NMC in all the applications, so it's important to have some rules on how to recycle LFP. And this could be also boost and foster circularity, also linked to what Carlos said before, because it's important to recover LFP, maybe in a longer term with an inner circularity in the battery sectors, but also by secondary source. But nobody in Europe can produce lithium iron phosphate at the moment. And this is crazy because I don't know, but if you know that, but China is putting some control on export starting from the early days in November on all the battery components. So Europe is really becoming a too passive key player, too passive consumer. So it's important to wake up and try to do something and use all the secondary phosphorus resources we have in Europe from other, with a symbiosis with other sectors, with an inner circularity in the battery sectors, but this should be regulated in the battery regulation. Now it's time.
Yeah. Carlos or Matthias, before we hand it over to the bigger audience.
There is already a, I want to take this up because I'm not firm in what really makes sense and what not. Yeah, so I know all the instruments that are there. Kees Langeveld writes, I think the best way to create a pull to recycled materials is to declare a quota for recycled products and a system of certificates comparable to CO2 certificate trades. I'd like to enter this into the discussion because I find this very interesting. I've this often, but I don't know, how do you see it, my co-panelists, and later also the larger audience? Is this really, do you also consider this a way or the most promising way to go? Do we need something in addition, or how do you see that?
Okay, I think if it is regulations are good as long as they are not too regulated. This is basically we are asking for regulation, but in that case we need also to be free to create the market, and the market is moving by itself. I think the first challenge we have on the table is to get this project running. This is the first thing, that we have to have the first plant of FlashPhos, let's say, running. And this will take 5 years from now to get some industrial potentially. In the meantime, we will learn how this will move. And once again, I insist in regulation is one thing, but nobody will invest a significant amount of money if it's not a clear long-term view of the business. Because if we don't have, and then the regulation is automatically there, because I need for example, the generator, the plant, the sewer sludge generator has to commit to deliver the sewer sludge or the ash or whatever for 20 years to me. Otherwise, I will not be able to form a business plan. And then if I have the sewer sludge, then, of course, the specification have to be the necessary one. But we need a long-term view, 20 years, and then you need the regulation. If it's not regulated, nobody will invest. We will have a fantastic project, fantastic product. We say always, and make a bit of verbum here, the phosphorus we are going to produce is better than the phosphorus you can buy today, and even the secondary material will be much better than the ones produced today. But we will not see it if we don't have a solid plan and regulated that people can commit for 10 or 20 years.
Yeah.
Thanks, Carlos.
Yeah, but Carlos, this do you hear me?
Yep.
Yeah.
Yep.
Yes, Carlos, I think this is a very important point. But we also talked about about this, that we need a market. The market will do it. Will create the surrounding that it needs. But maybe this leads us to the other part, or the second part of the question: are there maybe other instruments than these binding regulations that the European Union could provide, which would be incentives, which could be a support for an approach like FlashPhos, for any other approach because FlashPhos is, say, a niche in the market. White phosphorus is a niche, at least in terms of amount, on the market, and it will be, say, all these high quality products. They will be these technologies will be quite expensive compared to the agricultural use. So direct use of sludge in the agriculture, which is still over 80% or 70% in the EU. And so I have also the idea I think I'm not alone, that for this we need some incentives. I think also the pull that Case says, yeah, is quite would be quite good, yeah, to have a regulation, not in terms you must, but a regulation that makes it easier for these recycling processes of any kind to enter into the market, to also really fight this competition with the agriculture, which is still the strongest because it is the cheapest. So in this direction, is there anything that is really practical that we can expect for the future, that we will get some support by the European Union?
I think we should open this question now, also the discussion now, to the broader audience, because I think you have swallowed your 30 minutes. So I really would like to encourage other people to also bring in their opinions and their ideas and thoughts into the discussion.
Yeah, Case was raising the hand. Please,
Yeah.
go ahead. We cannot hear you, Case. Probably on mute.
Or wrong microphone attached. So
Yeah,
next to
we
your
cannot hear you.
microphone symbol, which is in the top right most likely, you can choose which microphone is the input.
That's the best. Take it off.
Can you hear me?
Yeah, now we hear you.
Yeah,
Okay.
finally, your voice is there.
I'm very much in favor of this quota system, because I feel every day that the fertilizer industry and the off-takers of fertilizers are very conservative. And if we don't give a pull to the use of recycled phosphates, everybody will keep on using the rock phosphate-based materials. And we see the best example in what is happening in the plastic industry at the moment. Recycling is going to die out because virgin material keeps on being more cheap than the recycled material. So you need here and there a push from authorities that say, okay, let's put a quota for maybe something like 10% of material to be coming from recycled sources. And if there are industries who cannot do this because of all kinds of technological issues in the fertilizer industry, maybe the use of ammonium nitrate together with recycled material, they can buy certificates from others who can do it for 90 to 100%. Then you will get an open market and you will get a better starting point for your feasibility studies in all kinds of recycled technologies.
Yeah.
Thanks, Keith.
Everybody is silent now.
Yeah, you shocked everybody.
We have to think about an intelligent reply. I really find this intriguing. Yeah, that's should be possible. Yeah, the question is there the political will to do so?
There is a will in the EU at the moment from the composers of the fertilizer product regulations to update and redo the FPR legislation in Q1 next year. And one of the things they want to check is, can we introduce a quota system? So I think this is the moment for the forum that is sitting here in this meeting to make some noise that we want it, because I can tell you that the major producers of fertilizers don't want it. So they want to kill this initiative.
Yes.
So we have another raised hand now from Luigi.
Luigi, yeah.
Oh, yes, from my point of view, no, from industrial point of view, do we think that there are already some technologies that are ready to cover this pro quota regulation, so to ensure such a quantity of recycled raw material that will allow the industry to maintain the production while ensuring these recycling quantities. I think this is also a matter, in my opinion, that together with the regulation, the important is also to have the proper technology for recycling. That is always much more complicated rather than a typical, I would say, a linear approach. Also considering the continuous change in the technologies. So, for example, the change in the technology of the batteries, the change in the technology of other innovative sectors that could lead to maintain a very complex scenario for the recycling, because you needed to adapt your technology to the scrap that you will get in the future. So also in this case, the approach that Carlos was referring to the next 20, 30 years is very, very difficult to have it, because you needed to realize, I would say, a plant that is able to work with a very wide range of raw materials and quality and so on. And it is also valid for FlashPhos, because we need to realize such a plant that could work with a very wide different sources of sewer sludges, qualities and energy required, and so I think that together with the regulation and the matter of the recycling, it's also a matter of technology, in my opinion.
Yes, but Luigi, you bring a very important point, a fundamental point, technologies. But if you, and I'll take now over what Kay said before, if you would have a regulation where you see some protection of at least a portion of the market, you will be able to invest and to look for investors, because the frame will support you. Then today you don't invest because nothing is regulated, and you are competing openly against China or whatever. China is always mentioned as a cuckoo, but anyway, somehow we are fighting against it. If you would have the regulation, even the regulation could be progressive and giving space for investment and so on, you will invest. You will find investors to do that.
I totally agree with Carlos that you can make it a flexible percentage, that depending on the situation, you review it after a couple of years and you adjust the percentage of recycled material to be applied.
Yeah.
But it gives in a certainty to the feasibility of these projects.
Correct.
We have two more raised hands. I think we have Veronica Santoro, and then I think we also have Maria Cristina again. So.
Hello, can you hear me?
Yep.
Yes.
Hello, everyone. So I'm Veronica from the European Sustainable Phosphorus Platform. I wanted just to connect with the last thing said by Carlos, because yes, it's true. So at SPP last year, we had a workshop trying to discuss with the stakeholders which could be the possible market pools for having this recycled products taken up by the market. So products are there, but it's very difficult. They are very expensive to produce, and so often the comparison with virgin material is, is not favorable for this product. So of course, regulation is one big opportunity, because if the regulation is not only an obstacle but should also be something that really pushes for recycling. So we are seeing now with the Urban Wastewater Treatment Directive that there will be some targets for phosphorus reuse and recovery from sewage sludge, and JRC is studying which are the technologies so that they could understand which could be the percentage. But in the field of agriculture, for instance, there is the common agricultural policies. There are some things that can be done related to agricultural ETS with carbon credits that can be somehow linked to nutrients. And to reply to the question of quotas, quotas are something that pops up really very often when we discuss about these tools. And one thing that we try to do at SPP is trying to understand which are the questions that should really be addressed when we try to make some advocacy for quotas, because of course could be nice, but we have a study that is now going on, and we should publish really soon the report of these studies on which are the questions. So what type of quota can we use? Can it be similar to some other fields? You mentioned plastics, so can it be something like that? Who should take the price of this quota? So that is something that we hope to have by the end of the year, or maybe beginning of next year. And also, this is something that is also considered by the European Commission, because DG GROW, that is in charge of the whole bioeconomy sector, let's say, they will also launch a study in 2026 on, they don't call it quota, but they call it amount of recycled material in some categories. So I think that will also be addressed in the next year, because it's very important, but also we think it's very important also to propose it in the right way. So not just saying, okay, we want quotas, but really understand what is the visibility behind that. So administrative, what does it mean for imports, and so on.
Thanks a lot, Veronica. Maria Cristina, I think you have 1 minute.
Yes, only two considerations following Keith as well as Carlos and Veronica comments. I think that recycling is not a matter of saving money. We all know that recycling is costing, is a matter of policy and strategy in order to get autonomy in strategic sectors. And according to this, we should be able to get specific funds in order to facilitate recycling. And I also think that niche markets like the phosphorus for industry can be the right opportunity, because it could represent a model to be then replicated into other sectors. So you don't have a strong economic impact in terms of cost, but you can have a strong feedback about the way to manage, because recycling is not only for phosphorus, but unluckily within Europe is for many strategic materials. Additionally, answer to Matthias' consideration about the carbon credits, we have to be also aware that they are becoming financial instruments. They can be, let's say, doped. For this reason, it is important to facilitate in a really pragmatic way leading labs out of the regulatory topics in order to experiment all these technologies and to create free zones where you can make trials and select the right technology for the right purpose. I think we should go for this.
Thanks a lot, Maria Cristina.
Sorry, but I'm airport and it's difficult.
Yeah. I would like, I think, Eliana, do you want to add anything from your side?
No, I think that more or less the context is quite clear.
Yeah, I thought so. Thanks a lot for your inputs. I would like to hand over now to Lena again to do the second interaction with everybody, so you can use the same window you had before to get your closing remarks.
Exactly. So I hope you can see my screen again. It's the same code. Actually, you can also just open the same window as Heidi said, or just scan the QR code again. And then the last like finishing sentence or interaction would be: complete the sentence. For the EU to achieve self-sufficiency in phosphorus for all major applications, it requires. So in this case, now you can also add more than a few keywords. You can just add a few sentences or whatever you think might fit best here. I mean, we already discussed many important things, so feel free to just summarize your most important points. It would be great. already looks great. Again, for this interaction, you can also add various responses if you want. You can just click on add response then.
Good relation with China is very cool point.
Yeah, I thought so too. Okay. I think it's a great summary actually of everything we just discussed. So I think no, okay, still 2 participants typing, then let's wait a little more.
This is going to be a novel. Maybe should we interrupt?
Yeah, I mean, you can still fill these sentences out. You can still add your responses and yeah, it will still be active, the poll. So feel free to also add something now after the workshop, and then you will see it later when I write the article about the workshop. Okay, there's the last response here. Perfect.
Super.
Thank you so much for your active participation. Then I will stop sharing.
Thanks a lot for facilitating this, Lena. I think this was really good to have some interaction also
Very good job.
with the broader audience.
Very good job. Thank you, Lena.
The closing words will be done by Luigi Di Renzo from Italmatch, who is also heavily engaged in FlashPhos.
Thank you, Heidi. I have this huge responsibility of closing this very interesting session with so very high-level discussion. I would say, from my point of view, I had several takeaways related to the regulation, the impact of them to the industry, and I would say also the matter of the industry development. It must not be only related to a linear approach, but to also a circular one. In any case, I would say that going back to our initial question mark about if there are some conflicts between for the phosphorus, I would say there are no conflicts between the various possible uses of this phosphorus, but I say that possibly not calling it probably conflicts, but problems with the actual industry could be that there are. We need so probably I would say an intervention of the politics, and the regulation works to drive a little bit towards a precise direction, the various industries and the various interests. But a part of this, I think that for the next step, I would say we need to work, not to continue to work to prove the various technologies and the various activities that our projects are working on. I would say Renovate, Nenufar, and FlashPhos, because I think that we need to prove, first of all, not the possibility of the technologies, and to convince the investors that some, I would say, reliable recycling technologies are available, or that they could be developed very soon and could be useful in the market. I think that this could be probably, I would say, a summary of the discussion of what we had. There are a lot of points that we raised during these 2 hours, but I think making a summary, would be, I would say, this takeaway can be taken by every one of us.
Thanks a lot, Luigi.
Thank you,
Luigi.
Okay, so this was very intense and very, I think, full 2 hours. Thanks a lot for your contribution and for your feedback and for your inputs and for your interaction. I think it was really a pleasure having you all.
Thank you.
Thank you.
Thank
you.
Thank you for
Bye
all
bye.
the interesting
Bye-bye.
information, and
Bye-bye.
Thank you.